This is our very last automatedbuildings.com session for AHR 2023, and it's gone great. And a lot of you have been in a lot of the sessions, and I just want to thank you all for being here. And it's been a fun journey this year. So our last topic here is a little education for y'all. So there was a guy, there was a man who could not be wrecked by corporate America, who could not be held back by people telling him what he could and couldn't do. He said, damn you all, I'm gonna build a training service in this industry. And whether you think so or not, you're all gonna end up loving it. And after quite a couple years, couple thousand podcasts, and some very good work, I think Phil and Smart Building Academy have truly arrived. I think they're going to be a big part of our industry for a while. And we're really excited to have Phil, the founder, the president of Smart Building Academy, here to give us just a little education, a little sneak peek of some of his stuff. And Phil, thank you. Turn it over to you.
Thank you, Scott. Welcome. All right, so last of the day. Here's what we're going to do. We're going to do something a little unique. I saw a lot of you respond to my LinkedIn post about what you'd like. I saw some stuff around cybersecurity, around, hey, can you teach me like crazy variable length subnet masks? And then some folks, can you spell IT for us? We'll kind of end up a little bit in the middle. What I want from you all, if you're cool with this, is I'm going to go through slides. But if something doesn't make sense, we could totally throw out the presentation and just have a chat. This is your opportunity to go and ask anything you want about IT networking. If I know the answer, I'll give it to you. If I don't know the answer, then I'll find you the answer. Is that fair? That work? Cool. All right, so how many of you all know who Smart Buildings Academy is and who I am? Fair bit. Okay, I'll give you then the 10-second spiel. Like Scott said, we run training for these system integrators, building automation contractors, OEMs, owners. And one of the things we do teach is IT. So I have do I need to explain my background, or do you all trust me enough to be great? Good? Okay.
Not at all.
Not at all. This guy was super shady. All right, so let's just dive in, save some time, get you more information here. We're going to talk about networking lingo. So how we teach, just so you know, is I often throw a lot of concepts at you and throw a lot of terminology at you. And then I will use the terminology in the concept. So if I initially go through the terminology and you're like, that makes no sense, I'm going to use it again and again and again until it sticks. Because one of the things, how many of y'all work with IT departments? Have you ever gone into an IT department, used the wrong lingo and just watched them shut down? So donuts and proper lingo are the way to win over any IT group. So they want to help you. They want to work with you. My goal is after this, you'll have the lingo. I can't give you the donuts. You can get that on your own. But you'll get the lingo and you'll get the concepts. That's my goal. Hopefully I achieve it. If I don't, please tell me. So we're going to go through network lingo. We're going to look at the journey of the packet. We're going to talk about what you need to know to succeed with IP. Talk about some IP architecture implementation scenarios and live question and answer. We're also going to maybe design some subnets. I don't know if we get the time, we'll see. All right, networking lingo. So let's get ready. OSI model. Who has seen this? Show of hands. Okay, about half of them. All right, so this is the open, by the way, I butcher acronyms. I just do it no matter what. Like, you could ask me what BAS is and I'll probably get the wrong acronym. It's just something about me, it's a quirk. But OSI model, Open Systems Interconnection Model, this describes the physical data link network and transport, and ultimately the session and presentation and application layer. So I'm going to spend some time on this because I found in my career that if you understand this, you will start to understand all the other IT concepts. So physical, this is the actual ones and zeros that are going across your Cat 6, Cat 7, Cat 8 cables. What happens essentially is you have these digital signalers that modulate a DC voltage signal, and that creates positive or negative, and depending on how you define bits, that creates ones and zeros. That flew over their head, just so I can kind of get it rated. Okay, everyone's good? Good, okay. One person. All right, cool. Well, basically what happens is there's an electrical signal, right? And when that electrical signal turns on, that signal's data. When it turns off, that signal's no data. And computers interpret that to build a message. So what happens at layer 1 is your data signaling transfer across the wire. Layer 2 conveniently is called data link. It's actually a split layer. It's the data link and is the media access control layer. Basically, this is where MAC addresses, this is where your local area networks exist, all right? So this is all of our traffic that we traditionally see within a local area network. Go to network, and I promise you, we're only gonna go to 4. We go to network, and that is your internet protocol. So right now you have Ethernet frames. You've got, right, your network packets, and then you're gonna have your segments at layer 4. So packets, and we're gonna talk about encapsulation and decapsulation of that as well. So what happens is your IP communication, right, is wrapped by an Ethernet frame, and that Ethernet frame goes from host to host. Like I said, we use a lot of terms that make no sense. It'll make sense as we get through this. So it goes from host to host across a local area network, decapsulates, opens up that IP message, that ultimately decapsulates and opens up the UDP or TCP message that's inside of that. Okay. Let's keep going. Where does all this happen? It happens at a network interface card that is on a host device. It's important we use this language, host device or node. In BACnet, it's node. In IT world, it's host. We want to use this language because this is what the IT folks are expecting us to say. It brings credibility. This basically has a hardwired physical address for layer 2 media access. And it's one of the reasons why initially when IP controls came out in the BAS industry, if you had a bus architecture, not a ring, not a star, but if you had a bus and you lost power to one of those devices, everything else downstream from it would go offline because these had to go and take a message, process it, and send it out another network interface card. That's what was happening. Now they're electrically bridged in a lot of manufacturers, so that will just pass through if you lose power. All right, MAC addresses. It's a hexadecimal physical address that's hard-coded to the host device. This is not BACnet MAC address, so it is not the 8-bit octet that you flip the dip switches and it gives you an address. This is a hexadecimal address. First 3 octets are organizationally unique, so this is to the manufacturer of the NIC. Next 3 octets are to the network interface controller. This is your first, so you all asked about cybersecurity as well, sprinkle that in here. This is your first potential point of cyber, also not your first, but it's one of the larger potential cyber issue areas is MAC address spoofing. People duplicate the MAC address, they put a device on the network, your network that has no other form of authentication except for MAC, and it thinks that this device should be there, and it shouldn't. All right, LANs, local area networks. This consists of host device, access links, trunk links, switch device, and a routing device. So we've seen host devices. You're starting to see how this builds up. This is a local area network, and it's defined across a single broadcast domain. This will make sense later, because we'll talk about what broadcasts are. So switch, there are layer 3 and layer 2 switches, but for our example here, we're just going to focus on layer 2 because it'll just get crazy confusing. So we're going to do layer 2 switches and we're going to do layer 3 routers. Realize there are layer 3 switches though. So a layer 2 switch, what this is going to do is it's going to allow the access links to connect to the hosts and access the network. So when you're talking to IT and you say, I need to hook up in a star pattern my supervisory device, you want to use a access link for that host or node device to access the network switch. This typically is all on a local area network, but we'll talk about VLANs and broadcast domains and all that jazz in just a minute. Then we have our switch ports and trunk links. So switch ports are where the access link is going to plug into, as well as where the trunk link is going to plug into. Trunk links are for networking devices, so a switch to a router, etc. Why do we have trunk links? Trunk links allow us to do what's called VLAN trunking. So VLAN is a virtual LAN. And what that virtual LAN allows us to do is basically create a logical network that can stretch across multiple physical LANs. Okay? Who's lost? It's okay. All right, where did you get lost?
I'm just trying to digest all this, and the one question I have in my mind is if you were trying to take a building management system, any kind of control system, and go to the IT department,
Yeah.
just ask them, do you have certain specs that we have to meet? Because I'm trying to figure out all this stuff, or listen to this, and I'm trying to think, how would you be able to sell that into that organization if you didn't even speak this language?
That is a great question. That's why a lot of people can't sell this into organizations and why we still get systems that don't work and can't be integrated. But to answer your question, typically the IT group will have an IT standard. That IT standard will not be communicated to you until certificate of occupancy because they don't typically put the actual switches in the MDFs and IDFs until the building is built and air conditioned. So it's kind of a conundrum with IP controls. We've got to build our little own OT networks and connect them to the IT network. So I see kind of still that deer in the headlights look, and that's totally cool. What I will tell you is that when we get to the examples, which hopefully we don't run out of time, if we do, I'll pull you aside, I'll make sure it's clear to you. But what we do is we essentially have a list of questions we need to ask. And then based on that list of questions and this underlying information, we're able to then approach IT and say, hey, I have this many IP devices in this building on this floor. Here's the MDF. What subnet should I be on? What VLAN should I be on? This is what I want to do. This is the amount of ports I need. Those are the things we're going to communicate. And then they're going to communicate back and say, this is your IP address range. This is your subnet. This is your default gateway, etc. I promise those terms will make sense in just a little bit. Anything else? Cool. So switch ports, they can be unmanaged or managed. Most of the dumb, and I say dumb, not because they're stupid, but just they don't have intelligence. The Netgear, the Linksys, kind of 5-port blue things you stick in your panels, those are called unmanaged or dumb switches, meaning they have no way for you to manage the individual ports, to put VLANs on there, things like that. And then there's managed switches. That's, I believe that's a Cisco switch. Maybe not, I can't tell the color. But no, I should know, I put the picture in there. So the managed switches, they allow you to manage the ports, to manage VLANs, manage trunking, etc. All right, access links, like I said, allows us to access the network, carries typically a single VLAN, and connects between a network switch and a host device. Sometimes multiple host devices in the case of bus or ring architectures. Trunk links, these connect between the actual switch and the router or something, maybe a wireless LAN controller and a switch. They exist to, the real main point here with trunk links is they're typically going to be your higher bandwidth links because they're going to carry multiple VLANs across them. It's a virtual LAN, and that allows you to segment data traffic. So what's going to happen is those trunk links are going to interconnect between those networking devices, switches, routers, wireless LAN controllers, etc. Alrighty, routers. So what happens is with this traffic, it communicates on what's called a broadcast domain on the local area network. So IP networks have subnets, sub-networks for typically private address ranges is what we use. And what happens on these sub-networks is they can only communicate to other host devices on the same subnet. So IP addresses are logical constructs. You cannot go buy an IP address. You can buy a network interface card with a host or with a MAC address, cannot buy a IP address. Well, I guess you get a public address from an ISP, an internet service provider, but couldn't physically hold it. So what happens is on that subnet, what the router allows you to do is to take traffic from one network, one sub-network, and route it to another sub-network. Who has seen the old pictures of the ladies sitting on the stools at the old telegram and telephone stations actually switching circuits. See that? That's called circuit switching, all right? What our networks do in the switches is called packet switching. So we take IP packets and the switch switches it from one port to the other port or to the default gateway, also known as gateway of last resort. And it sends it to the router, which then says, oh, you need to go to this subnetwork. Here's how you do it via a route. So we are concerned with packet switching, and routers facilitate that across networks. Still making sense? Good. I know this is a lot, but it's really, this is where the stuff falls apart on these projects, is the simple, I say simple, but not easy, simple concepts, because I yet to meet a owner, IT group, who will let me go into their Cisco switch, go into the CLI, that's the command line interface, and start setting up VLANs. If they do, they're really dumb. That I would never let someone do that. So this you can communicate, but they're still going to do it. Routes, this is what a routing table looks like. Literally, we'll say, oh, you want to go to this subnet, then go out this port, and the port has an IP address, and it has a port identifier. IP address composition. Am I good to step over here and stand still? How about now? Am I still in frame? Do I need to go back?
Go back.
Well, then I'm going to block the view. So.
Yeah.
All right. So IP address, we're only talking about IPv4, not IPv6. Now I got to move now. We're good. So, sorry, it's so hard to install. 32-bit logical address. So it consists of 8 octets. So 8 sets of 1 or 0 bits, right? And 4 of those. These bits can be either network bits or host bits. Network bits identify the logical network address. Host bits identify the logical host address. So what happens on a network, we see this little symbol. Have you all ever seen this and wondered what this is, this /24? Anyone? Okay. Okay, so you all are pretty advanced. Good. All right, so what that means, though, is that 24 of those bits are reserved for the network. 8 of those are reserved for the hosts. Okay, so that means that I have 2 to the power of 8, which is 256, minus 2, which I'll get to later, host bits available. Actually, it's minus 3 because you have to set the default gateway as well. But you have that many host bits available to you for the network. Still making sense? Good. All right, so we have 2 types of addresses. We have public and private. Public addresses, what these allow us to do is route across the internet. These are what your ISP gives you. I'm not going to get into port address translation or network address translation here, but then we have private addresses as well. Private are what we're going to be using in our building automation projects. Typically, we're going to say, hey, we need 64 hosts because we have 64 backnet devices. And so then we will typically do like /25, which is going to be 2 to the power of 7. You have 32 bits, 25 out of 32. So 32 minus 25 is 7. 2 to the power of 7 is 128 minus 2. That gives us 126 host address that we can use, which is some basic subnet math. All right, so we're going to do that with private addresses. We have address classes. I'm going to kind of skim over this, A, B, C. Key point is you probably, yes, sir.
On the previous slide, the /24.
Yes, sir.
Is there any reason why a manufacturer would do that as opposed to giving you the 4 boxes for a subnet mask?
When you say 4 boxes, you mean 4 octets?
Yeah, why wouldn't they just, like on a regular computer when they put subnet mask and you fill in 255, 255? Like, why did they do this?
I mean, you can do 2, so that would be 255, 255, 255.0.
Yeah.
It's typically a lot easier for people to digest a /24. But if you were to go into your IP settings, or you were to go into an actual CLI on a router, you would typically, to your point, use the full subnet mask. And then even then, if you have to use a host mask, then it would be 0.0.0.255. So if you're trying to do some stuff VLANs.
So there's no, it's just the manufacturer's preference.
Yeah, and it's short speak. It's just a lot easier, you know. If you've ever designed like a hospital network or something, if you had to write out 255 on, you know, it would just take a while. So it's just easier to do /24, and then, you know, just copy paste.
Okay.
Great question, though. So, and feel free to interrupt me at any time of questions. The more interactive you are, less likely I'm going to fall asleep. All right. A, B, and C. So what I want you to focus in on right here is private range. We've all gone to our corporate offices and we've seen 10 dot whatever. That is a class A. That means that it is a /8 private address, which gives us 16 million hosts. Now, I didn't talk about the fact that there's only a set number, I think it's like 2 billion public addresses that are available. And we use this concept called subnetting and private addresses to give us this private pool of addresses that we don't use up. And then we use network address or port address translation to allow them to be routable to the internet. I'm not going to really dive into that because to be totally straight with you, it's not pertinent to be a BMS unless you're going to cloud or you are doing maybe some like wide area network work, which most folks who are doing that are competent and I don't see them messing it up. I see them messing it up kind of at that office building or that single school, and they're just getting VLANs mixed up with this kind of concepts. All right, so like I said, class A, class B, class C. Then we have our CIDR, right? Let's get an acronym I'm already. I think it's classless interdomain routing, but I'm not certain. So CIDR right here is going to allow us to go and define that /24 somewhere in here. I don't know, maybe, I'm sure it's in there somewhere. So no, it's not. But what it'd be is, you know, a 24 would be /24, you know, 16 be /16, /8, etc. And you can go up or down. We'll talk about that in a second.
The /24 is underneath mass weight.
There it is. Thank you.
Yep.
Here we go. Static versus dynamic addressing. Static addressing, we used to have to do this because we didn't have domain name services. So you'd set up an address on a supervisory device. Someone would change that address or use it up. Your supervisory device goes down. There's no way to resolve it. Big common issue we used to have with a lot of servers and soups out in the field. Nowadays, most stuff has a domain name like google.com. Well, in this case, it may be like buildingabas.com. And that domain name matches to an IP address. So as that IP address maybe changes, that domain name stays the same. And that solves that issue. But still, a lot of people like to do static addressing and not dynamic addressing. This is how addresses get assigned. Any questions on this?
Are there any security concerns with static addressing?
Denial of service attacks. You could do that. You could also do like some reconnaissance. If something has a static pool and you know where the start and end of, for example, a bus run is, and you can get the start and end, you could then get how many devices are on that run. So you can do kind of little neat tricks like that with different network enumeration tools. So yeah. But like I tell people, and please take this, and if your engineers completely disagree with me, if you do, it's totally cool. But what I tell people, sort of like, oh, we need DoD cybersecurity at this, you know, quick trip. And I will say to them, for example, like an office building, this is a great example. Like, well, someone could go and they could, you know, bring a lift in here and they could get up to the device and they could unplug it and they could put a foreign device in. And I say, well, isn't the bigger issue that someone literally like drove a lift into the conference room and it's in the ceiling and no one stops the thing? Like when I was getting my master's in cyber, they talked about this one pen test that this guy did where he literally wore a shirt that said, I am a hacker, and was bringing in boxes, big manila boxes full of health files, and the boxes were labeled private health files. He was wheeling it out of the hospital repeatedly to just see if anyone would say anything to him. No one did, because he had a badge on. So, I mean, FISEC is like, you can have the greatest cyber in the world, but your FISEC's not there. That's physical security. All just falls apart. I don't see that getting spec. I see a lot of cyber stuff getting spec, but FISEC is critical. Yes, sir. Yeah, absolutely. You know, there's logical cybersecurity controls, administrative. So you want to use those administrative controls, not just the logical and technical controls. All right, so here's how stuff communicates. We use unicast. I'm going to give you, did I get to unicast later? Okay, yeah, I did. I'm going to give you backnet examples for unicast, multicast, and broadcast, because it kind of more sticks to what we do. So IP communications with a subnet, basically what happens, you have this thing called address resolution protocol. It's a table that exists within the switch. It keeps a list of all the IP addresses and the associated switch port. It refreshes itself typically every 5 minutes. What happens is the switch will send out a broadcast. And when that broadcast, well, actually what happens is the host device says, I'm trying to communicate something. Sends out a message to switch. Switch doesn't have that entry into the ARC table. Switch sends out a broadcast to all the devices on the local area network. And then what happens is those devices will then communicate back, and they will say, we're this IP address. That ARC table gets built out, and then from that ARC table, now the switch can communicate to those IP addresses. If it's not on that same subnet, it'll go to the default gateway, and that default gateway will then go and communicate back to the router, which will then look at the routing table, and then we'll go to the other subnets, which we'll see in the very next slide. So host IP address, switch, gateway, route, down to another subnet. Pretty straightforward, right? Any questions so far? Switch hands. This gets heavy. I mean, it's like one of those, have you all ever seen that one movie, The Punisher, where he leaves the guy in the room? Well, I can't be the only one who's watched this. And he's holding the bomb, and he like leaves him there, and his like arms are broken, and he's like holding it, and if he lets go, it blows up. No, we've seen that. Come on, really? Safe space. All right, unicast. So basically what happens, there's a reason I showed you this. It looks crazy, right? Who feels like totally a little anxious when they see this? Pretty crazy. At the end of the day, so this is actually how a Tor router works. So that's the onion router. It's basically how people encrypt stuff and go on the dark web. So essentially what it does though, at the end of the day, this is a unicast message. Source IP, destination IP. Source IP, destination IP. It's really that simple. And when we do BACnet, so if you're doing a read property, if you're doing a write property, that is a unicast message. It's a complex acknowledged message from a server to a client, I think, or maybe client to server. I always mix up alpha and bravo communications on that map. But essentially, that's a unicast IP message. Then we have right here a much simpler. See this crazy complex, this super simple. All right. All it is you just, like, if you ever get confused, just pull the complexity away, try to, put white out on stuff, and just look for the piece of information you need. Okay, multicast, right? See right here, unicast, multicast. This is a multicast group. Okay, or sorry, broadcast multicast group. I got this from my Cisco book. So what's going on here? Multicast is read property multiple, write property multiple. So if you do a read property multiple, like maybe you are grabbing a bunch of points off some sort of tree, and you say, show me all the Z and dash C's, can you tell I work for Johnson in the past? No, they're still there. You can call out. All right, so ZN-T, standard for them, right? That's how they name them. So if I were to do a poll of all the devices that had ZN-T, that would be a read property multiple. So it would go to my multicast group and it would read all those properties. And then finally, as I said, broadcast. The important point here is broadcast domain. We've had a lot of students who they've got their subnets mixed up, or they didn't have the proper subnet defined on their BDTs. That's a backnet distribution table on their BBMDs, which is backnet broadcast management device. They didn't have those properly defined. So the who is I am and the who has I have, which are broadcast messages, those are discovery and backnet, those could not be shared because each individual subnet, not LAN, but subnet, because sometimes multiple subnet will stretch across multiple LANs, so we call it VLAN. What happens is that subnet traffic cannot transfer across broadcast domains. Does that make sense? This is really important because a lot of people have backnet BBMD issues and BDT issues because they don't have routes set up properly, they don't understand subnet overlap, etc. All right. Ooh, sorry. Default gateway, that's where traffic goes, known as gateway of last resort. It's where things go when it says, I need to go to a different subnet. How does it know this? Through the CIDR mask. That's the most common question I get is, how do I know what subnet I'm on? Because of that CIDR mask, that /24, that tells me that anything else may be a different subnet. Well, it is a different subnet. It's not may, it is. Okay, broadcast address. I promise we're almost done with the terms. But is this useful? Am I like talking too low level? No. Okay, cool. All right, and so broadcast address, right? So there's 3 addresses on a subnet. Okay, and this is important because a lot of people miss. There is the network address. This is the first address of a subnet. It's typically like a .0. So on a 192.168.1.0, that is the network address. That is not a host address, but it subtracts from that 256 addresses on a /24. Then the last address is 255 in that case, and that is the broadcast address. That's where all broadcast address traffic replies to, right? That is the broadcast address. Well, actually, what happens is that's the sending address, and then actually typically will reply. Do you guys want to know this? Okay. Basically, what happened? One guy shaking his head no. One guy shaking his head yes. Suffice to say, what happens is, depending on what you're doing, typically, what actually happens technically is the switch wraps the broadcast message in an FF Ethernet message that gets sent out to all the hosts on the physical VLAN or LAN, and then they reply back to the switch to build that ARC table. That's how broadcast works. The backnet, who is IM, is a little bit different. It builds a backnode list, it's an array, but basically same concept. So that address is the last address in the range. And then you have your default gateway, which does not have to be .1. It does not have to be the first address. It can be any host address on that range. It's typically .1, it's the first address, but it doesn't have to be. Subnetting. All right, let's learn subnetting in 5 minutes. So here we go. Determine, you laugh. I told people I could train Texan too. So subnetting. Let's do that. Determine the network of subnets required. So how do you do this, right? Well, first we have to understand what a subnet is. So we go way back. And right here we see, okay, with this we have 16 hosts, 256 hosts, 128. So we need to pick a number that can fit the amount of hosts we need minus 3. Most people teach -2 because of the network address and the broadcast address, but you also have to have the default gateway. So let's say we have 16 BAS devices. We can't do right there /28. we would have to do a /27, which would be 32. Make sense so far? Okay, so once we've defined that, now let's say we have 3 separate networks of 16 devices, then we know we need 3/27 subnets. That's the first thing you're going to go to IT with. I need 3/27 subnets. Okay? And typically what IT is going to say is, all right, what did I do? Push too many buttons. Here we go. IT is going to say, well, we're using a Class C address. You can start with 192.168.1. And then what you'll have to do is define the range. And you're going to go to subnetcalculator.com. Told you I teach you in 5 minutes. You go to subnetcalculator.com. You're going to type in the private range, C. You're going to type in the number of addresses that you need. And you're going to type the subnet that they gave you. And it's going to give you everything I'm going to teach you in here. So I'll have a link to that, by the way. What's going to happen? You're going to get how many networks? 3. How many hosts do I need on each one? 16. And what class am I using? C. Okay. So in this scenario, I use 2 with 124. I'm going to go here, right? I'm going to go and pick what mask works. I already talked to you all through this. In this case right here, this would be a /25, right? /25, because I'm counting my default gateway and my host, right? And so what we would do from there is we pick our class C, typically, is what we use. And what? I've never used this button before, folks, and so let's use it right here. Right here we go. I'm gonna move.
Good. You can see yourself right there in the top window.
Oh, that's nifty. So here we go. I'm gonna say, okay, Class C. I'm gonna go through all of this stuff. I'm gonna pick my range. And then what's gonna happen is I'm going to get these 2 ranges right here. 192.168.1.0 is that network address. 127, last address is my broadcast. This is my usable host range right here. And same right here. I get this information quite simply by using this calculator. There's much more complexity to this, but IT and your business owners are not going to reward you for complexity and fanciness. Just ask them what subnet, ask IT what subnet they'll give you. Figure out how many host devices you need, and please use this calculator. It does all the work for you. Okay, if you want to take pictures of that, it's an amazing website. Oh, let me take pictures. And we're gonna fly through a lot of stuff now. Okay. VLANs, virtual LANs, this lets you take multiple physical LANs and apply a subnet across multiple ports. You need managed switches to do this, and you can apply a VLAN, typically IT will apply the VLAN to the individual switch ports, and this creates a virtual LAN. So while you see VLAN 30, and you see a switch here, right? This logically looks like a single switch. Physically, it's 2 switches. Logically, it's 1 switch. Does everyone understand what I mean when I say physically versus logically? Does anyone not? That's totally fine if you do. Oh, okay, good. All right, encapsulation. Like I said, I've already beat this to death. All right, segments, packets, frames. Anyone confused on this? As we go down towards the physical layer, we wrap the messages more and more. As we go up, we unwrap the messages. The technical term is encapsulation. It's just easier to say wrap and unwrap. Just don't say that to IT. Kind of goes against the whole point of the presentation, right? Wrap those thingies. So the package journey, I just want to talk through this real quick. Single subnet, let's say host A here wants to reach host B. What's going to happen is we're going to have additional signals standard at layer 1 called physical encoding. That is all going to be set up in the switch port, how it encodes its messages. But the Ethernet frame is going to wrap the IP address or IP packet, which is going to wrap any TCP or UDP messages. They're going to be sent to the switch. The switch is going to look at its ARP table. It's going to say, oh, that's off port whatever. It's going to decapsulate down, right? So it's going to decapsulate down to the packet, and then it's going to, because the source Ethernet address, destination Ethernet address, and then it's going to re-encapsulate the source Ethernet address and destination Ethernet address, and it's going to send that frame out. And it's going to encode it and send it out as bit signals. Pretty straightforward. Awesome. So multi-subnet, what's going on here? Everything's exactly the same except for any time you transition a link, there is that encapsulation and decapsulation of Ethernet. So if you've ever looked at Wireshark and you look through messages and you're trying to kind of trace out your backnet IP messages, see where stuff goes wrong, and you see source and IP destination and it never changes, but well, it doesn't technically necessarily change. If it's like a BPMD broadcast, it'll change. But if it's a unicast or multicast, it shouldn't change. So that's not going to change. But what is going to change is those Ethernet source to destination. That's important to know because as you troubleshoot the message, if you see that your Ethernet source and destination, great to the switch, great to the router, nothing else, tells you probably have a routing table problem. If you see that it gets to the switch, never gets to the router, probably have something wrong with the trunk link. I've seen like quality of service issues where someone's streaming IP like 4K. This is really notorious in the healthcare situation where they do 8 or 12K cameras for remote surgery, and they put them on the same trunk as maybe your VAS traffic. And what happens is the video traffic gets a quality of service tag, which says this is high priority, and your traffic to date, I'm not aware of any VAS contractors that quality service or OEMs that quality of service tag their VAS traffic, and I don't think they should. It's not really feasible in most cases. But what happens is it says this isn't important because it has no tag, so it's going to get dropped, and that camera traffic's going to go through. And so that's something you can find by simply saying, like, where am I losing my frame messages? Make sense? Okay, cool. All right, what we need to know to succeed with IP is super duper simple. With new construction, right? We have a LAN, or we have multiple LANs. They're going to consist of host devices, access links, trunk links, switching devices, and a routing device. We need to know our host device counts. We need to know what switch ports we are connecting to. And we need to know what VLANs we have so we can make sure we have routes. This is going to be the same on new construction and existing construction. The big difference here is you're typically, if you're doing IP controls, you're going to have to implement some sort of OT industrial switch to set up your initial network, and then either wrap that into the customer's IT network or pull that out and then plug your stuff into where the IDF MDF switch ports are. So how do you all do this currently on new construction? What's y'all approach? I mean, I've been talking for 40 minutes now. Let's get interactive. Anyone, there's no wrong answer.
So I'm with GSA on the federal government side, so all of our stuff sits on the GSA network. So for like our new construction, we'll typically have the control center come in, they'll have their own network, they'll ride it, and then we'll transition over to our federal provided network switches. The big thing though, he nailed it, making sure you have your MAC addresses set up, and then our IT guys will give IP addresses. The biggest issue I see with this is they whitelist the device, which is a security measure to allow that to communicate on the port. if IT does not set that up, you have communication issues.
Yeah. And then if they take their little 5-port Nexus switch and pull multiple devices into it, and they've got, MAC address max 1 on that port, and then it sees 4, and it locks the port down. It sets off a bunch of alarms in the NOC, so in the SOC, fun stuff. Good to do at like 2 a.m. in the morning. Existing construction, surprise, it's exactly the same, right? New construction, existing construction. The thing is, with new construction, is all these things exist eventually. With existing construction, they all exist now. So you have to figure out, like, okay, what am I going to plug into? What are my switching devices? What are my access links? What are my host devices? What routing devices exist? What subnets? And this is the real kicker. New construction, you can get away with like subnet overlap. On existing construction, you may go to a 192.168.1.1.0, I have to do it in my head, /24 network. But someone may have a /27 sitting on that, like in the middle, because they just want to be that person who takes the middle of the range for no good reason. And so you're like, oh, great, I got 192.168.1.0/24, 256 addresses, this would be awesome, good to go. And then you try to put something on there and you're getting all these issues and things are just going offline and people are angry because maybe they're streaming Netflix on that range or something, TVs. But what happens is they can do what's called variable length subnet masking. They can take slices of a mask. So you got to be very careful for that on existing construction, especially hospitals, airports, corporate office buildings. They're notorious for giving you a subnet mask that is a non-secure subnet mask, but that's also like running the digital signage, or it's running, for example, patient kiosks that are, navigational, not PI data, not private data. And then all of a sudden you plug in and you take down all the patient kiosks or the infotainment. So yeah, it's no fun. So any questions about that? Pretty straightforward. Cool. We're doing on time. All right, I promise we'll hurry this up and get the questions. So IP controls deployment architectures, star bus ring. Star, point to point. This is what we've always done. This is good for servers. This is good for built-up air handlers. It requires a single port, so it can be very expensive if it's a managed switch and IT is leasing these ports. It can cost a lot because like a PoE layer 3 switch can cost 8 to 12 grand. So for 48 ports, you divide 48 into that 500, 600. I'm not good at math. So we figured that out. That's not good to say in front of a bunch of engineers. I'm horrible with math. I'm going to teach you IT. All right. Bus pattern. This is a ring right here, right? Or sorry, a bus. And this is MSTP basically, but it's not MSTP, it's IP. With the newer controllers that most manufacturers have, they have decoupled their network interface switches on these controllers to be able to continue to communicate in the case of power failure. But if your main port right there goes down, you still will lose communication downstream. So a lot of people are investing in ring. This started in the industrial world. And what this does is one port is open, the other is blocked using this concept called spanning tree protocol or rapid spanning tree protocol. And the blocking port will stay blocked and all traffic will go there to prevent a loop. And if something fails, the blocking port will open and information will go the other way. All right, implementation scenarios. We're gonna go through this real super duper fast. Yes, sir.
On that ring, that has to be a managed, like, does that have to be a special switch? Or
Not a special switch, but
it can't be a hub.
well, no. So that's a great question. Let's talk hub switches real quick. Okay, so a switch sends stuff out on single ports, right? Unless it's broadcast in L4. A hub sends everything out on all ports. No one should be using hubs. Guess you buy them on eBay. I don't know where you would buy a hub. I'm sure you could probably buy them somewhere. I just don't know where. But you should not be using hubs. And to your question, like I said, I'll tell you if I don't know. I'm not 100% sure if unmanaged switches support spanning tree protocol. I'm pretty sure they don't, because you have to set up the timing on the spanning tree for switchover. There's like a ranking algorithm that says which port takes lead and stuff like that. And you have to set that up. And rapid spanning tree, I know, is something you have to enable on the ports. So,
And that's what creates the one directional ring.
absolutely, yeah. So,
When it opens up that other port, does it leave the first one open? So that, let's say it broke right in the middle, you still.
it depends. Going back to my Cisco days, some of their Cisco's probably in here. Wrong. I believe the blocking port opens and there's a word for it, the root port closes. So it should be root and blocking port, I think, are the technical terms. Sorry, and then I'll give you.
Well, I think they both continue to operate because if you have it open.
Oh, yeah, thank you.
Sure.
Thank you, yes, you're absolutely right. And then, I'm gonna say something, Scott.
Question, do you need to make sure your switch supports the proper protocol when you start to look at a ring pattern?
Yes, so it should support spanning tree protocol at a minimum, although realize spanning tree protocol is slow. It's like the 30-second switchover, which is usually okay for BAS, not for industrial. And that's why Cisco, back when I used to work with that stuff, they licensed rapid spanning tree protocol. I don't know if they publicly allowed that to be on non-Cisco switches now. I don't know, so don't quote me. But that one has like sub-second switchovers because it's used in the industrial space. Yeah, great question. So you definitely want to, if you're a specifier, make sure that that's accounted for if you're using more. Yes, sir.
Again, just on the hub, so if you had 3 IP controllers and a panel and a mechanical room, you still shouldn't use a hub to connect those.
No, it'll be an unmanaged switch.
Oh, so you can use an unmanaged switch.
Yes, if you have 3, and then you'll use a star pack.
Okay.
I don't know that once you get like 5 port switches that say hub, I don't think they're actually like old school hubs. I don't know that you can really find those like.
No, I agree with you. I'm just trying to eliminate that word from y'all's vocabulary. So if you talk to IT, you don't say hub, and they're like, what the hell is this person saying?
So, like say from Contemporary Controls, they sell an unmanaged 5-port switch.
Yes.
That's not a hub.
That is not a hub.
Okay.
It's just an unmanaged switch. It'll still do switching. Yeah.
Okay. All right.
Yes, sir.
Little off the beaten track, should still have some hubs for wires not captured. You can't capture all the data with the switch anymore. Back on track.
Yeah, I mean, so there's ways you can do that. You can, depending if it's a managed switch, you could potentially put protocol analyzers that actually sit on the managed switch. Cisco iOS has tools built into that for you to capture that, and you can actually export it into a PCAP file, which is Wireshark's capture file. You can do promiscuous mode on Wi-Fi, which will enable you to do certain things.
But if you're an engineer or a tech that doesn't have access to a switch for a customer, you ain't doing that.
Yeah, I would not recommend that. Like, I made the mistake of doing, what's that software? I can see it in my mind. It's got the big eye. Nmap. I did an Nmap aggressive, so you can pick profiles on Nmap. And I did an aggressive scan at a hospital, and that like lit up their IDS, which is intrusion detection system, like a Christmas tree. And I'm freaking out. And I got in trouble. That's good.
Or you can just unplug and run.
I mean, look at me, dude. Do I look like I run? I mean, maybe if there's like a pizza somewhere, I run. Yeah, then we have to. No, you just donuts, man. And if it's really bad, like you did where I wiped out a lawn database at a hospital, then it's like steak and donuts. Yeah, donut and steak. It's a great sandwich. All right, so ring pattern, like I said, pretty straightforward. We are 5 minutes. I've got time. I want to be respectful of your time though. So we can go through some implementation scenarios. Quite frankly, I don't know how much you'll take from this because I just realized it's lunch, so show up. So why don't we do this? We'll do the utterly amazing fact prepare and go ready. All right, Skip knows what's coming. It's been through these before. Prepare to be amazed. 100% of the questions that are not asked during the live question and answer session do not get answered. I know that is shocking, but that actually is true. So, can we do it? Yes, sir.
So Phil, they talk about opening up ports to allow access outside of the networks. Could you, I know you didn't get into detail on that.
Yeah.
Could you add a little commentary for the crowd?
Absolutely. So there's two types of ports. There are physical ports and there are logical ports. Of logical ports, you have two types of logical ports, because why can't we just have? So logical ports are going to be UDP, which are known as connectionless, right? Unreliable. So basically it's fire and forget. Now folks are like, that's UDP, but it's still reliable. I can talk about that offline. But there's UDP ports and there's TCP, Transmission Control Protocol, which that's how basically everything works in the world. You create a connection and then you get a sequence and it comes back and forth and messages are reliable because it's send, acknowledge. So how many of y'all install a server, BAS server at a customer site? It's not working. First thing you do, you turn off the firewall. Always me. I've done it before. And it's just kind of what I did in the past. I didn't understand the ramifications of what I was doing. But what that does is that essentially opens up every possible port. And now services, Windows services run on ports. Linux services run on ports. And what happens is these services, what they do is they allow, so we'll talk about APIs for a second. Application programming interface allows you to interface with the programming in an application. And it provides services typically through a port, like HTTP, Hypertext Transport Protocol. I promise you I'm going somewhere while I'm giving you all this information. Hypertext Transport Protocol enables you to connect to a web page, right? So that's port 80 typically. If I open port 80, now if I have a software vulnerability or something with my server on port 80, and I open that up, people can exploit that. That's why it's very important, to your point, long way of going there, but it's important to only have the ports and services open that you want exposed to either the intranet or internet. What else can I answer for y'all? I'm here for you. I know. I didn't think I would get through the acronyms, honestly. I was like, I can get through these legend slides. What are y'all running into? What can I mean, I'm an open book. What can I share with you? Was this a good use of your time?
Yes.
Okay. Was this informative? Yes, sir.
In your BACnet SC device and your certificate expires, does it just brick?
So what you'll get is well, if you're using a web browser, you would get this is an unreliable certificate. I'm not sure how each individual OEM is implementing that, whether they do a conditional, I would imagine that they don't automatically fail. I gotta imagine that's a setting because people are forgetful and you don't want a hospital in the middle of surgery like losing connection to its OR devices. That would be bad. So I've got to imagine it would generate an alert, but I can't speak for the individual OEMs, how they're implementing it.
We do that.
It feels.
So we generate an alert.
Yeah, that's what I would imagine would happen. It would generate an alert.
But you ignored it.
Well, it's going to keep generating
And
alerts.
your certificate expires. What happens?
It's going to keep generating alerts. Just like if you
doesn't correct. I thought they said it cuts communication. It is dead.
I mean, I can't speak for each OEM, but I think that would be a horrible design decision. Because let's say your certificating authority takes 3 days to a week to go through IT, and they can't go to that, because I don't care who you are, like, let's say you're like NASA or GSA or whoever, and you go to certify or whoever the certificate authority is, and you say, I'm the GSA, I need my certificate now, and they're gonna say, and I'm not picking with you, sorry.
3 days.
Yeah, they're gonna say, I don't care. 3 days, yeah. And you're gonna call your rep and be like, you now, they're gonna say, can't do anything. And so then your system shuts down. I think, no,
My understanding is it doesn't completely brick, it just doesn't communicate anymore. And until the certificate is renewed, then communication goes back up, but the device will still operate.
well, it'll still operate, but I would be shocked if they don't allow communication anymore. I don't know. I would have to ask the OEM because, like, I mean, that's kind of scary. I mean,
The webinars yesterday, they said that they would stop.
okay.
They did in our last
4 or
session.
5 different things.
So they did in the last session too.
This is why I must become my boss. This is why I get my hand slapped every time I talk about this topic.
Just a real quick comment. I don't think all this has been vetted out.
Yeah.
Honestly, I think I was questioning both Johnson Controls and Delta at the end. Neither one have full product lines flushed out yet to really, so.
I do not speak for OEMs. I speak for our company. I'm not to say that people who are way smarter than me don't have it figured out. I'm just telling you as a guy who, has done a lot of stuff, I mean, it seems like it would be a bad idea, but I mean, what do I know?
I think what I've seen is communication continues to communicate unless the device reboots or the connection is lost.
Yeah, and then it can't authenticate. Yeah.
When the connection comes back, then
Which that would make sense, because the cert is literally your 802.11ax or something, or 802.3ax, one of those ones. And that's your way of authenticating.
already established the connection.
Yeah, so that connection should stay. But hey, I mean, it used to be, quite honestly, where IP controls, if you had them in a bus and the device went down, you'd lose the whole bus, and they fixed that. They were like, this doesn't work. So, I mean, voice of customer, all of you, just say, hey, oh, maybe you have 2 levels, and you say for a data center, no, but for an office building, sure, yeah, that's fine. It's up to you.
At the end of the day, it's easier than most.
What's that?
I said at the end of the day, it's easier than
You're still trying to get me in trouble. I just got out of jail for the, now I'm getting back, now I do, man. Yeah. FT10, like you could put baling wire on lawn and it would work.
stretch wire just a little and have impedance errors and never find them.
Yeah, well, that too. Or you could wipe out lawn databases at hospital and be unhappy. So, don't do that. What else, gentlemen, ladies? I told you, I guess you left it. I did. Okay. Thank you. I appreciate your time.